So let me get you record. There we go. All right. Last time I left off, I was talking about the tree diagram. And how that can be used to do or analyze probability problems. And the one I left off was on problem number 7 on page 522. Okay. Now let's say here that a probability experiment consists of drawing 2 marbles, one at a time without replacement. And there are 2 blue marbles, which is labeled B, 1 green marble, which is G, and 3 yellow marbles, indicated by Y. Okay. And here that probability tree diagram is shown up here on the screen, and also I have that same probability diagram up here on the board. So I'm going to be referring back to that from time to time. All right. Now the next slide are the examples here for that particular problem. Okay. And it says here, determine the probability that the second marble is yellow, given that the first marble is green. And then part B, determine the probability that the second marble is yellow, given that the first marble is yellow. And then determine the probability that the first marble is blue and the second marble is green. And then part D, determine that the probability that the first marble is yellow and the second marble is blue. Then determine the probability that the second marble is yellow. Okay. So starting with part A, I want to determine the probability that the second marble is yellow, and that's given that the first marble is green. Okay. Probability that the first marble is yellow, the second marble is yellow, given that the first is green. Well, these right here represent the first marble. And then these represent the second marble. So here we're going to be working backwards here. So in this case, we're given that the first marble is green. So here's the first marble, and it's green right here. We want the probability that the second marble was yellow. Okay, so here's yellow right here. The second marble is yellow. We're given that the first marble is green. So the probability there along this tree, along this branch right here, is just simply going to be 3/5. Okay. We're not worried about the 1/6 for the probability of the green marble, because we're already given that the marble was green. We just want to know what the probability is for the second marble to be yellow, which is in this case 3/5. And that's all there is to it. Okay. Questions about part A? Now, part B says, determine the probability that the second marble is yellow, given that the first marble is also yellow. So now we look at the first marble. It was given that the first marble was yellow. We want the probability that the second is going to be yellow. So from yellow to yellow, that's your probability right here. 2/5. And I do need to mention, if they ask for a percent, then 3/5 will be 3 divided by 5 times 100. For part A, that'd be 60%. And for part B, 2/5 as a percent, 2 divided by 5 times 100. That'd be 40%. Okay. Any questions about parts A or B? All right, part C. Here we want to determine that the probability that the first marble is blue and the second is green. Now this time it's not a conditional probability as parts A and B. Okay. And also it has the word and. So that means we need to do multiplication. The probability of a blue, selecting a blue, times the probability of selecting a green marble. So the first marble has to be blue and the second marble has to be green. So let's find the branch from here to a blue marble and then from a blue marble to a green marble. That would be, might need to do this in a different color. That's to a blue and then to green. So we multiply those two probabilities here. So from here, the probability of a blue is 2/6 times the probability of getting a green. In this case, is 1/5. Okay. So 2/6 times 1/5 . 2/6 times 1/5, I'm going to do 2 times 1, that's 2, then 6 times 5, and the denominator is 30. And then as a percent, 2 divided by 30 times 100.
6.7.
Okay, so 1 decimal place would be approximately 6.7%. So in this case, the probability of that the first marble is blue and the second marble is green is 6.7%. Okay. Questions on part C? Okay, part D. It states we want to determine the probability that the first marble is yellow and the second marble is blue. So part D is like part C. Got the word and in it. So that means we need to multiply those two. The probability of getting a yellow times the probability of a blue marble. So the first marble has to be yellow and the second has to be green. Let's see. That's yellow. And then to blue right here. Okay, disregard that branch, yellow and blue. So yellow to blue. The probability of getting a yellow is 3/6. Times the probability of getting a blue, that would be 2/5. So if I do numerator times numerator, 3 times 2, that's 6. Denominator times denominator, 6 divided by 5, that would be 30. And that's going to be how much? 20%. Okay. Questions on part D. Okay. And finally, part A is determine the probability that the second marble is yellow. So here we're looking at the second marble that's yellow. Well, let's take a look. We got this possibility that the second marble is yellow. We got this possibility that the second marble is yellow, and this possibility that the second marble is yellow. So now we have to look at the branches that's going to get us to the second marble being yellow. So if we start up here, we have to go from yellow to yellow. So we need to look at the probability of getting a yellow and a yellow. And then we have to add to it. For this one, we have to go from a green to yellow. So we have to get the probability of a green to yellow. And then we got this second marble is also yellow. To get there, we have to go from the blue to yellow. Okay. And guess what? We're going to have to do some multiplication here. For a probability of the first being yellow and the second marble being yellow. That's along this branch right here. So here, the probability the first is yellow is 3/6 times the probability of getting the second yellow. That's 2/5. And then plus the probability of getting a green and yellow. So for green, that probability is 1/6, and for yellow is 3/5. So that's 1/6 times 3/5. And this last one here, the probability of getting a blue and a yellow. Well, for a blue, its probability is 2/6, and for yellow, it's 3/5. So it's 2/6 times 3/5. Okay. So let's multiply what's in these brackets first. If I do 3/6 times 2/5, this will be 6/30 plus 1/6 times 3/5, this will be 3/30, then plus 2/6 times 3/5, this will be 6/30. And since these denominators are the same, I'm going to go ahead and add the numerators. 6 plus 3 plus 6. This is what, 15/30? And 15/30, in simplest form, that would be 1/2. which is as a percent, 50%. So that's part B right there. Okay. All right, so that's how we do problem 7.
Can I ask a question?
Yes.
I just did a mock-up as the second was blue and it came out the same. Is there a correlation to the fact that you're coming out with the same percentages as they were to begin with? Like yellow makes up half of the original marbles. Blue comes out to 1/3, which is exactly how many there are of the original marbles too. Is there a correlation to it?
Not really. This is a coincidence.
Okay.
Okay. Any other questions? Okay. There is one more that I need to do. It's this one. Says here, suppose you had a jar with 17 red marbles and 23 black marbles. You randomly select a marble from a jar without replacement. And what that means is you take one marble out of the jar, you're not going to put it back in. That's going to reduce the number of marbles you have altogether and the number of red marbles or the number of black marbles you'll have. If the marble is red, then you add 7 yellow marbles to the jar and randomly select another marble from the jar. If the first marble is black, then you add 13 marbles to the jar and randomly select another marble from the jar. Then you want to determine the probability that the second marble is a black marble, given that the first marble was a red marble. And then probability that the second marble is red, given that the first marble was a black. And then part C, the second marble is a yellow marble, and part D, the second marble was blue. Okay. So the best way to do this is to create a tree diagram, like the one that we just did. So let me erase all of this. So the jar started off with red marbles and black marbles. So I'm gonna let R be red. I'm gonna let B be black. So if there's 17 red marbles and 23 black marbles, the total number of marbles has to be 40. That's 17 plus 23. Okay. Now, the probability of getting a red marble, there's 17 red marbles out of 40. And the probability of getting a black marble is 23 out of 40. Now, let's say, let me do this. Let me put dots here and put the R here and the B here. Let's say you select the red marble. And the reason I'm doing 3 of these, because you will have a red and a black. But it does say you have to add 7 marbles. So you're going to have 7 yellow marbles here. That's where the Y comes from, yellow. Now, if a red marble is drawn, that means you're going to have 39 marbles left but you have to add 7 marbles. So you're gonna have a total of 46. Okay, so now on the second draw, the probability of getting a red marble, instead of 17 red marbles, you're gonna have 16. Because the first marble that you drew is red. So you'll be down to 16 out of 46. And for the number of black marbles, since that first marble drawn was red, you're still gonna have 23 black marbles, this time out of 46. And then the probability of getting a yellow marble, here we added 7 yellow marbles. So that probability will be 7 out of 46. Okay, is everyone with me up to this point? Good. All right, now the other part of the question is, if the first marble was black, so you'll be down to 39 marbles on the second draw. But we have to add 13 blue marbles. So here you're going to have a red and a black. And I'm going to say BL for blue. Okay. And then B for black to distinguish those two. But we're going to add 13 blue marbles to the jar. So that means instead of 39, we're going to be up to 52. So each one of these will be out of 52. Now, the first marble drawn was a black. So that means we're still going to have 17 red marbles in the jar. The probability would be 17 out of 52 because we added 13 blue marbles to the jar. For black, instead of 23, you're going to be down to 22 because the first marble drawn was black and there were 23. So you're down to 22 out of 52. And then we added 13 blue marbles. So that probability there would be 13 out of 52 for drawing a blue marble out of the jar. So that's our tree diagram. And now we're going to use that tree diagram to answer parts A, B, C, and D. Okay. In part A, they want the probability that the second marble is black, given that the first marble was red. I must have read that wrong. Second marble is black, given that the first was red. So this represents the first marble, a red or black. The first was red. We're given that the first was red. What's the probability for it being black? On the second was black. 20. It says 23 out of 46. Okay. And I'm not sure if they want this reduced, but it'll be 1/2. Or 50%. Questions on part A. Okay. All right, part B, the probability that the second marble is red, given that the first was black. So the first was black. That's right here. We want the probability of getting a red marble. So we go along here, red marble, that probability is 17 out of 52. Okay. How much? 33. I'll say 32.7%. Yeah, to one decimal place. And then part C, that the second marble is a yellow marble. Here's a row that consists of the second marble and it's yellow. For us to get a yellow marble, we have to start up here, go from a red to a yellow. So the probability of getting a red and yellow, that would be the probability of getting a red times the probability of getting yellow. So the probability of getting a red marble was 17 out of 40. And the probability of getting yellow, that's 7 out of 46. Okay. So in this case here, 17 divided by 40 times 7 over 46. If I multiply that by 100, that would be about approximately 6.5%. Okay. Questions on part C. And then part D is the probability that the second marble is a blue marble. Okay, let me give me this. The second marble is a blue. Now let the L be blue. So this is right what I'm looking for. So to get to a blue marble, I have to find the probability of a black marble and the probability of a blue marble. So it's probability of black and blue. Probability of a black multiplied by the probability of blue. So the probability of getting a black marble, that's 23 out of 40. Times the probability of getting a blue, 13 out of 52. Let's see what this is as a percent. 23 divided by 40 and times 13 divided by 52 times 100. So one decimal place, this is what I get. 14.4%. Okay. All right. Any questions about that probability tree? Okay. Or any questions about section 9.2? Okay. Okay, so that ends section 9.2. And the homework for that will be available for you to complete. Okay. So let me do